Hi friends, my name is Rian, your tech master at Azure DevOps Pulse. Be welcome to our YouTube channel. In today's session, we'll be learning about Docker, and this will be the first session on Docker topics. And total, we have 7 modules, my dear friends, such as getting started with Docker, image creation, management, and registry, networking, orchestration, installation and configuration of Docker, enterprise edition, security, storage, and volumes. So let's get started with the introduction to Docker. Docker is an open source software platform that simplifies the process of building, shaping, and running applications by using containers. So Docker itself is open source. Okay. So let me split this into 3 categories. First, when I say that it simplifies the process of building, shaping, and running application by using containers. Okay. So I will split into 3 parts now: building, shaping, and running application by using containers. Okay. So let me first explain about building, right? So I will take you to the GitHub where I have the code. Okay, this is my code. Let me give an example. You are working in a organization as a DevOps role. Now, your basically one of your developer has developed the code that is your ASP.NET code, let's say. Okay, develop the code and post to GitHub. So right now, think this is just consider this is your actual code in your organizations, and okay, they have pushed to your GitHub now. So till now your code is available in your GitHub location, in your GitHub repository. Okay, so now like I mentioned, you understood first. We when I said the ASP.NET code means, or could be something, it can be a Java, Python, or maybe any other, right? So it depends on the technology they use and application it use, right? So in our case, just let me give an example. In our case, this is very simple ASP.NET Core. It is available right now in your GitHub, right? Now, what will be the first priority? How are you going to? What is the requirement of the project? Let's understand now. Okay. Now, the requirement in the project is that this particular application, what you see here, the code, this is a code base, right? You have a, let's say, you have so many files, so many dependencies, so many other, you will have everything, right? If you go inside, you will have so many other things, let's say pages, okay, like that. You'll have so many other things. So basically, what I'm trying to say is that you have a code already till now. Now your work as in your DevOps, you have a they have asked you to deploy this particular application in Azure Kubernetes service using CI/CD, Azure DevOps CI/CD pipeline. So how are you going to do this one, right? How can you perform this task? So like I mentioned here, as you can see here, the first thing is a building, right? So what you'll do, based on your existing ASP.NET Code, you will write in your same directory of your application code, in your same directory, in the sense within your root directory. Okay, in our case, this is my this root directory. What you do basically here, okay, let's say this is the application code, you have everything. Now inside here, okay, in your directory, root directory, what you do, you will write the Docker file first thing. And again, this is again the again project to project, it may varies the role and responsibility, okay, and the company you work, right? So let's think you're the responsible person in your organizations who has to write Docker file as well. Okay, so this Docker file basically is written based on my existing application, which is ASP.NET code, as simple. Okay. So if you see here, basically the from basically is it is basically a base image. Base image is nothing but in our case, like if it is a Ubuntu or any kind of this thing, you have to mention. In our case, it is a .NET, right? So we will mention the base image SDK as 6.0 something, right? So this is your base image. So one more thing, team, whenever we write any Docker file, the from is your whatever you see these all your is, let's say, from working directory, copy, run, expose, and the entry point. What are these actually? These are all called as or known as instruction. Okay. So in basically whenever you basically write any Docker file, they have a different instructions. Instruction is nothing but you have to define the task to do certain activity. Let's say in our case, like I mentioned, base image we need to choose first is important. In our case, base image is your .NET code with particular SDK version, whatever 6.0 or whatever. Okay, and then we have your working directory. Basically, what I mean, what I said a default working directory within your container. Okay, because once you go this thing within your working directory, I mean within your containers, you will set the default working directory that is your slash app. So then you will copy this one. You will use another instruction known as copy instruction and dot if you see dot space dot actually it is not a dot. You have to give some space in between. Okay, one space in between. So it is a copy dot space dot. Okay. So when I space give it this dot double dot, what happens basically? What basically if I said first thing you have to understand this one. When I set a working directories, I set as working default working directory as slash app whatever is your within your containers. Now within a container, whatever commands you run, basically that will be running within your container itself. Let's say copy and it will be within containers. So what basically if I copy instruction, what it does basically is that if you just let me open another tab. Okay. So when I say copy, it's nothing but whatever you have a file here in your root directory, right? In your GitHub, basically, whatever root directory you have here, in our case, inside here, there's so many files are there. Let's say it is for the Kubernetes service. If you want, you can check it if you want. Okay, like this will be written. And same thing if you're going with the services, you need to expose some services, right? So it is defined here. So like that, this is some of the what your focus is to other application related things, right? Properties or anything. You will have so many. Basically, whatever you have the core is available for particular ASP.NET code. You have all entire basically the cores and things are there, right? So everything with the what they will do from the root directory, whatever inside you have within your root directory, they will copy, and they will keep within their copy where they'll copy to their containers within the containers inside this particular location that is your slash app. Okay, then what they will do after copying like once they successfully copy the what you call that what you call the dependency, right? I mean the once they copy the whatever you have the files, everything applications related things, what they will do is that they will actually what they will do is that they will restore the dependency. Here means they will restore the dependency. As we all know, whenever we are working with any of the technologies, let's in our case we are working application that is your ASP.NET code, we will use what you call that NIGAT package manager or management. Okay, if you're going with the other, let's say if you're going with the Python, they'll use a Python PYP. Okay, and if you're going with the Java based applications, they will use the package managers such as Maven or Gradle, etc. And if you're using like let's say for JavaScript or maybe Node.js, you mostly be using npm package, nothing but your node package manager. Okay, so each technology and application it varies. They have their own kind of package manager which they use it. Okay, so in our case they'll use a like I mentioned, we are using the what you call ASP.NET Core based applications. So we use a .NET base, I mean NIGAT base, NIGAT npm, sorry, NIGAT what you call the package manager, and they will restore everything like your libraries or dependency which is required for your application to run within your container inside your slash app directory. And then okay, so then once you're basically what you restore everything, whatever what is required for your application, okay, once they have restored everything, then what they will do, they will what you call restore is done, right? And then third is your, I mean this is your one two three four, okay, this is the one that is your run, right? So in run command, what it will do basically is that they will build it, okay, they will build and publish it, they will build and publish it, and then they will build whatever you have, they will all the solution once they have got your like libraries, dependencies and the code what you have, once they define everything, what they will do here is they will build and publish, okay. Then once they publish, they will also expose the port, okay, they will expose the port for containers, okay. Once they export, then and the last we also have your entry point. Entry point is nothing but what it does, it shares the default commands, okay, to run when container starts. So whenever the container starts, they that is your, in our case it is a .NET, right? So whenever it starts, basically what it will do, you have to set the commands, okay. So in our case, that is our .NET, okay. And in this particular location, if when we work with your ASP.NET Core, we have this kind of DLL file. Also within this directory, they will be executed. Okay. So in simple terms, whatever you see this kind of the instruction in your Docker file, it is based on the tasks. Basically, I mean based on the existing application, it is written here. Like okay, once we are good with now this one, right? That is your Docker file. So once you have done the Docker file creations, what you'll do is that you will, based on this Docker file, whatever you are given the instruction, you will build the image now out of this particular, like I mentioned here, right? You will build the image now from your Docker file. Docker file is already, you have written a Docker file now already. Now based on the Docker file, whatever you have defined in your existing applications, the image will be built. Once image is built now, that means your image is located, your image is good now. You now, sorry, my bad, huh? You now your build is process is done. Okay, you have built the image that is now considered as containerized based application. Okay, it is a containerized based application now because it is no more in code. Okay, it is basically as a containerized application base. Okay, now second is your shipping. Shipping is nothing but it is a deployment. Deployment is nothing but now you have the image that is your containerized based application. Now again, it is depends on your wish. Where are you going to deploy, or where are you going to move it? Whether you want to deploy to Azure, or whether you want to deploy to Azure, I mean GCP or AWS, or let's say in our case, if it is in Azure, in what kind of service? Let's say it is, whether it is for Azure Web App or VM skill set, or whether you want to deploy in your Azure Kubernetes service, right? So like I mentioned, your requirement is to deploy in your Azure Kubernetes service. What you do now, you are going to deploy that one. Okay. You, in our case, you can define now, you can ship that one. Then we will run the applications by using containers now. Now, okay. So when I say containers, basically what container it has basically, containers, when I say containers, basically it's a lightweight isolated environment that package an application's code, runtime, system tools, system libraries, and settings, etc. Meaning, when I use, like I mean, if you see here, this is a running application by using the containers. So it requires a containers. Without containers, you will not be able to deploy your application as a containerized applications. Okay. So in our case, they will use. So this is first thing is a lightweight and also isolated environment. Okay. So whatever you have the application to run particular specific applications, you will have everything in place. Let's say applications code, runtime, and what you call system tools and system libraries, etc. Okay. So this is known as Docker. So in simple terms, when I say Docker, basically, you will first build the applications based on your existing the code what is available. in your, let's in our case, I have shown you in GitHub, we have a code, and based on that, I have written the Docker file. Once Docker file is being created, I from the Docker file, I'll build the image. So that will be a containerized image now. Okay, now once it is ready, now you can now deploy the Docker image what you build basically. Now you can deploy anywhere you want, whether you want to deploy in cloud, Azure, DevOps, sorry, Azure, AWS or GCP or anywhere, right? You can deploy. So in our case, we are going to deploy in our Azure AKS, that is Azure Kubernetes Service, and we are going to run. But we will also need to install one of these containers. So like I mentioned, container it has your application runtime, sorry, code runtime, system tools, and etc. We have it. Okay, so okay, this is why we are using Docker. So let's understand some other things like components, some of the key components of like Docker here, such as Docker engine. What is Docker engine? The core engine responsible for building and running the containers. So if you want to run your the containers basically, right? You need to have this, that is a Docker engine. Engine basically will be installing, right? This will take care his responsibilities to build and running the containers, because like I mentioned, without containers you will not be able to uh, provision, or sorry, you will not be able to deploy basically your application, right? So that is why you will have to install, that is your Docker engine. Once you install this Docker engine, basically his responsibility is to building and running the containers. Okay, so we don't have to think, they will take care everything. Okay, they will. And then we have a Docker file. Docker file, like I mentioned, I have already shown here, this is the Docker file. The basically Docker file, when I say, we can see the definition, it's a script defining instructions to create a Docker image. So if you remember, like I mentioned, we have existing application, then we have given the instruction here, like what is a base image, where what kind of directory has to set, what I need to copy, where I need to copy, what kind of, what you call that, like restoration, or maybe the dependencies need to be this thing. Everything you will define everything here in your Docker file as instructions. Okay, so that is why it says the script defining instruction to create a Docker. So instruction means you have given the instruction such as this instruction. Okay, like do first A, then do B, then do C, like that. Okay, all right. So let's go with the next one. Docker image, right? A Docker image basically is a snapshot or template used to create containers. And Docker containers is an executable package containing applications and its dependency. And we have a Docker Compose. This is also very much important. It's a tool for defining and running multi-containers applications. Let's say, in our case, if you have a one or two containers, somehow it is good, you can manage it. But in a company, you will have a number of containers, let's say 30, 40, 50, hundreds, or more than 200, depends on the projects to project, right? So it may varies. So how are you going to manage it, right? It is not possible for you to manage everything manually, or maybe they can, no, there is just way of managing it. That is why what we can have, all right, we can manage using Docker Compose. Okay, so if you have multiple containers, this Docker Compose can help you. You can write a Docker Compose and it can manage the uh, containers. Then volume, we have Docker volumes, the persistent data storage for containers. We will understand anyway as we go along. And Docker network mechanism for container isolation and communication. This is more of the narrow network perspective. And we have Docker Registry, basically it's a repository for sharing and distributing Docker image. So let's say in our case, with the help of Dockerfile, you created Docker image, right? Docker image is there now, but so let's say this particular Docker image is located in your local system. Now, if you're working in a team, how are you going to basically collaborate with other team, right, or other person, right, in your team? So that is when, once the Docker image is ready or built, you will have to keep your Docker image somewhere in your centralized location. So that will help you, or you can share with others and also distribute the image, of course, right? So that other can also refer the image and they can use it as in when they look day one. Okay. So then we also have a Docker Hub. Docker Hub is nothing but it's a public repository of Docker image, as like just like the first that is a Docker registry. But this is a private one. And if I say about Docker Hub is a completely it's a public repository. Okay. Let's say if you want to see, I don't know if I have it, but let me check Docker Hub. So, okay, this is a Docker Hub basically. If you see, this is a repository. I have so many images I have pushed now to my public repository. Let's say Dockerfile and Azure, my India. So you can check this also if you want to see more. Okay. So this is basically if you want to basically share with others and all, no, you can check this one. I mean, you can use the Docker Hub basically. So if anybody wants to see or they want to do anything, you can create the image. Okay, like that I can see. So it is again depends on the project to project and the company to company how they want the images to be stored. So but normally as per my experience, company would not prefer to use Docker Hub because it is a public repository. But for testing or any kind of this thing, some you can also keep in your public repository like a Docker Hub, such as Docker Hub. And not otherwise normally you will use a private repository. Let's say if you're talking with about Azure, they will use a Azure Container Registry. Okay, we will anyway learn that as well as we go along. Fine. All right. Now we have understood about the Docker Hub things also. So fine. So let's go with the next one. And this some of the benefits of using Docker, such as portability, consistency, isolation, eligibility, for open source, collaborations, maintenance, and updates, scalabilities. So I'll just give a small brief. I'll not go much in details. When I say the portability is nothing but you can run your application anywhere. Okay, Docker anywhere. Docker is installed regardless of the operating system. So as long as you have installed the Docker in your system, you're good to use it. So okay. Second is your like consistency. Application always run in the same isolated environment, ensuring predictable behavior. And isolation enhance security and resource management by isolating application from each other. It can also help you to like prevent conflicts and vulnerabilities. And usability, we have a first development, testing and development life cycle. And like I mentioned here, open source, it is free to use, modify and distribute, fostering innovation and community. And we also have a collaboration where it is very common, easily share and distribute applications for collaboration and knowledge transfer. And you have a maintenance and updates such as update application and dependence within containers without affecting others. So this is one of the biggest advantage this also. So whatever changes or modification you want or maybe this thing you can update within your container itself so that other containers cannot be affected. Okay, you can also have a rollover updates quickly, so it can also minimize the downtime. And this is one of the advantage even this as well, that is your scalability. Easily scale application horizontally by adding more containers to handle increased loads. So if you get a like high like traffic or maybe requests, so definitely your the load will be increased, right? So at that time at the time you can basically increase more containers. You can add more containers based on the request. And whenever you don't want, I can put it like what do you call decrease it. So you can have a different kind of setup, such as you can have a horizontal auto scaling, everything. Okay. Fine. So let's understand about some of the challenges we face without Docker, such as dependency conflict, such as the application with conflict dependencies and portability issues, such as the difficulty in running applications consistently across environment and resource inefficiency, heavy virtual machines consuming excessive resource. All right, so now let's understand how Docker can resolve this problem. As you can see in the diagram, the comparison between virtual machines and the containers. First, when it comes to the virtual machine, we have a hardware infrastructure, and then we have a hypervisor, and then we have a multiple guest OS. And in each guest OS, we will have to install your libraries and dependencies, etc., and then you run your applications. Same thing if you had to run another applications, again you need to have your OS, guest OS install, and then install your libraries and dependencies, and then you can run your applications. And if you see here, the isolation basically is happening in your hardware level itself. Okay. And when it comes to the containers, basically, first we will have a infrastructure, hardware infrastructure, we'll have a operating system. And with inside your operating system, you will install Docker or something known as your Docker engine. It is responsible for building and running your containers because container is a lightweight and isolated environments where it has your application core, runtime, system tools, and libraries, etc. So without having containers, you will not be able to run your applications. Okay. So here, but then the isolation basically happening in the OS level itself. Okay. So this is some of the key points which have to understand. So if you like to know more about maybe containers, I mean, versus the virtual machines, you can read these documents, I mean, this as well. So I will just wrap up the session here. So thank you for joining today's sessions. I look forward to see you in the next sessions. Till then, take care. Have a nice day. Bye bye.